So I'm going to begin the talk. I'm going to talk in English because I think some people require it, I guess. So that they asked me to. Anyway, welcome. Thank you for having me. I'm going to talk about Node.js and a bit of the surrounding ecosystem of Node.js and the community. A bit about me first. My name is Pedro Teixeira. You can find me on GitHub and on Twitter under this handle. I've been working in software engineering since 1997, since I finished graduation. I'm currently the director at a consulting company called YLD, or Yield, or Wild, if you want to be funny. You can check us out at yld.io. We specialize in Node.js, and the company is based in London, and the customers are mostly in London. I'm also the founder and co-organizer of a Lisbon JavaScript conference called LXJS. It's been held every year since 2013. I think the first year was 2013. So it's a bunch of friends that organized a small conference that grew, and now we have 300, 350 people coming from all over the world to talk and to listen and to exchange ideas for 2 days in Lisbon. People have been asking this year there would be a 2015 edition, I think, mainly because we can't find people to help us organize it. Everyone is too busy, but we plan to do it next year. Regarding Node, I've been using Node since the early 2010, so when it was on version 0.1. It's changed a lot since then. Also on the subject, I wrote some books. This first one is called Hands on Node.js. Was my first one, self-published one. These two were followed for packet publishing, and then one called Professional Node.js. I wrote for Wiley, the publisher. And recently, like last week, I released a series of mini books called Node Patterns. It's a growing series of books, mini books ranging from 40 pages to 150 pages, that specifies on particular topics of how you can use certain patterns to build Node.js applications. So small code patterns and large scale patterns. NodeTuts, yesterday I released a new version of this website. It's called NodeTuts. This is a series of screencast tutorials about Node.js. So if you want to learn about Node.js, I recommend you go here. There are other sources, but this one I just released yesterday. At least the new version, because there was a previous incarnation of this project. But since I've been in Node since version 0.1, and it's changed a lot since, so I've had to redo all the tutorials like 5 or 6 times. Okay, so I'd like to see some hands on the audience and see who has heard about Node.js before. Yes, okay. Who has programmed in JavaScript? Okay. Who has played with Node.js? Who has developed a small application in Node.js? Who has Node.js running in production? Okay, cool. Nice. So, some of you may be disappointed because this is not a very technical talk. But I'm available in the QA for getting more into depth of the code aspect. So the agenda for this talk is to analyze JavaScript ubiquity. I have a bold claim that JavaScript rules the world. It will not rule the world, it already rules the world. We'll analyze industry adoption. What makes Node great, in my opinion, some Node use cases, and then the community aspect of it, and finally some time for questions and answers. But if you have any questions before, please feel free to interrupt me. I like to be interrupted. Can make this more conversational if you'd like. Okay, so first one, JavaScript rules the world. So you guys have heard of web browsers, right? Web browsers are programmed in JavaScript. So JavaScript was born for manipulating web documents, right? So anyone remembers dynamic HTML when it came out? So it was built for that. It took like 8 or 10 days for the author of JavaScript, Brandon Knight, to come up with that, to produce that language. And as a result, the language has some good parts and many bad parts. That's being kind of corrected. There are new versions of the language coming out with new interesting features. And the bad parts, you just forget about those and don't use them. But because of this, JavaScript has always been looked at like a toy language, right? And I'm here to show you that it's not a toy language. Perhaps you guys already know. Some of you have Node.js apps running in production. So another instance of JavaScript is Cordova, formerly known as PhoneGap. You guys know PhoneGap? Yeah. So it's a platform for building native mobile applications using HTML, CSS, and JavaScript. So basically, you build a mobile application that is cross-device compatible, like you build a web app. And you use native JavaScript APIs to access all the native components, like, for instance, the camera, the contacts, and all that thing, all those things. So it's a neat tool for prototyping an application, or even building a real one. A bit about databases and how Node.js touches them. CouchDB is the flagship of the NoSQL movement. So it's a database that uses JSON for documents. So it talks JSON back and forth over HTTP, and has JavaScript for MapReduce functions. It sounds a bit complicated, but it's not. It's really simple database. And when it came out in 2005 or 2006, people thought the author was crazy. HTTP, why should a database talk HTTP? But CouchDB is a very powerful platform, not only a database, a platform. People build entire applications using CouchDB. Then there is Riak. Riak is a distributed database that is very fault tolerant. So you can add and remove nodes from a cluster, and it self-organizes. So you can also program it using, much like CouchDB, you can also program it using MapReduce functions in JavaScript. So the way that you program it, both of these databases is using JavaScript. MongoDB, has anyone heard about MongoDB? Yeah. So MongoDB is fairly popular. It's even more popular. It came after CouchDB. Sorry, CouchDB. But has since become more popular because it's more user-friendly. It's easier to get started with MongoDB. But it's also a document database, and it has some JavaScripty capabilities. Like it talks JSON, not real JSON, like a binary version of JSON, JSON, and stores arbitrary documents inside it, and you can also program it using JavaScript. This one, LevelDB, is another database. I was not going to insert this one here, but because LevelDB doesn't have JavaScript in it, but You can use LevelDB and embed it into any engine. And you can then use JavaScript to access LevelDB database. It's a database that was built by Google, and LevelDB powers all the databases that Google has, like Bigtable and whatnot. And the Node.js, for instance, has embraced this database as the go-to database for embedding a database inside one process. The other use case of JavaScript is the Internet of Things. It's a bit like a bit of a buzzword, but I think it all started here with the node copter. Back in 2013, this is Felix Geisendorfer showing in the first LXJS conference, showing the parrot drone helicopter being controlled. You can see it here, the command line, the REPL. Is giving commands to, using JavaScript, giving commands to the parent drone, and the drone is obeying those commands. And since then, a NodeBots movement has emerged. So this is robots powered by JavaScript. So basically there are NodeBots spread out throughout the world, where people go and do hardware stuff and control those robots, whatever they do with JavaScript. One fun thing about the Nodecopter one. So Nodecopter events happen in almost all the JavaScript conferences now. People gather in places and they get one parent drone, and there are teams, each one with a drone, and then they compete against each other to see what applications they build around the drone. And the funniest one that I saw, and is referred here, is bullfighting with quadcopters. It's quite funny because the quadcopter has a camera, and it feeds the image of the camera is fed into the browser. The browser runs a detection algorithm. When it detects the red, the drone shifts toward the red and then charges. So you can put a red handkerchief like this, and then the drone will charge like a bull. And you can do bullfights with this. It's a lot of fun. One of the platforms that NodeBots uses is Johnny 5. So Johnny 5 is open source Fermata protocol based for IoT and robotics. So it supports a series of hardware, from BeagleBones, Arduinos, and Pinocchios, Raspberry Pis, and more. And also, I think this one is very interesting. It's called Tessel, and it's a microcontroller that runs JavaScript. Here on Johnny 5, it's you have to control the hardware with JavaScript from the outside. But this one runs JavaScript in the microcontroller. So it's Node.js compatible. The JavaScript that you run is Node.js compatible, and it can connect to Wi-Fi. And has GPIO ports, so you can do pretty much what you do with Raspberry Pis or with Arduinos. You can do with this, but program it in JavaScript, which is a lot of fun. And on the server side, Node.js, of course. So let's analyze the trends, the search trends in Google, to see how the interest in Node.js evolved over time. You can see here, Node.js was introduced by the end of 2009, November 8, 2009, and since then the growth has been exponential. If you compare it with technologies that have existed since 2004, 2006, like for instance Ruby on Rails. Ruby on Rails existed from here, and then just evolved from here. But now you can see that it's converging, and I hope soon Node.js will surpass the the Ruby on Rails framework. The comparison is not really fair because Ruby on Rails is a web framework and Node.js is much more than the web framework. It's like comparing oranges to peaches, but you can have a grasp of the dimension of the trend. But once you introduce Java, this yellow line is Java. You can see that this doesn't even get off the axis. So Java is much bigger than Node.js or Ruby on Rails, whatever. So we have a lot of way to go. And one funny story that I may add here is that when it was 1999, I was working at a consulting company, and I went to my manager and said, I think we have to create a web framework that runs Node.js on the server. I think it will be the next big thing. And he said, Java on the server? I don't believe it. I don't believe it's Java on the server. 2 years later, I ended up working in a startup, and their platform was Java on the server. So these things come and go. So let's see a bit about industry adoption. So as I was saying, it all started in November 8, 2009. So this young fellow named Ryan Dahl introduced Node.js during a conference in JSConf Europe in Berlin on November 8, 2009. By the end of his talk, he was met with a standing ovation. Everyone applauded his deed, his effort, which was to combine Google's V8, which is a JavaScript runtime, the one that's used in Google Chrome, to combine that with and provide and wrap the Unix network calls and expose them in JavaScript. So using JavaScript, you can make network calls using Node.js. Since then, countless startups have started using Node.js, and now it's 2015, and all these big names and much more are using Node.js. These are just a few examples. For instance, LinkedIn was one of the first big companies adopting Node.js for their serving their mobile traffic. And we'll see why mobile traffic is best served using Node.js. Walmart, the same thing a bit later. Walmart serves all their mobile traffic, which is huge, through Node.js. You guys have heard of Black Friday? Black Friday. So they serve Black Friday traffic, which is like, I don't know, 20 to 100 million users or something. The scale is enormous, and they run it through Node.js. Bloomberg recently said it was migrating all their PHP and Java stack to Node.js. Microsoft has been supporting Node.js since almost the very beginning. They sponsored the developer of the Node Core team. They support Node.js in the Azure, whatever it's called, with the cloud providing service of Microsoft. They support Node.js. IBM, of course, is also a player in Node.js through their professional services and their support of Node.js flavors in their mainframes and in their servers. PayPal has a lot of talks that you can check on the internet about how they're migrating from Java to Node.js, and how they're accelerating prototyping, how they're accelerating development, how they're getting more talent into the company just because of Node.js. Uber, for instance, powers the routing, the routing of the cars through Node.js. eBay uses Node.js. Dow Jones, I don't know how they use Node.js, but it's just cool names to have here. So why do these companies decided to start using Node.js? The first one is to attract talent. The places where these companies work at, Bay Area in San Francisco, New York, or even London, it's very hard to find good talent. And so one of the ways to find good talent is to use a sexy platform, a sexy language. And everyone likes Node.js, or at least most programmers like Node.js and would like to work on Node.js. And so this is a factor for deciding whether or not to go to a certain company. Also finding talent, which is a different point from the previous one. So finding talent, Node.js uses JavaScript on the server, right? So the browser, there are a lot of talent there that knows JavaScript on the browser. And the reasoning goes that if you know JavaScript on the client, you should also know how to program Node.js, because it's JavaScript, it's the same thing, right? It's not like it shouldn't be like that. It's not like that, but well, it's the same language, right? So people are more used to the quirks of the language, and they dominate the language, and so it's easier to find people that know JavaScript because there are so many front-end JavaScript developers out there that can be migrated into a Node.js backend developer. Also because Node.js allows rapid prototyping, iteration. This is very important. It's a very malleable language. And so you can rapidly create something, show it, and have weekly iteration or daily iterations. Some companies that I know push code several times a day. When they have instead of creating mockups for a new product, they just create it in Node.js right away. Maybe they have to throw it out later, but that's what they use for prototyping. Also for scalability. Node.js has a good scalability story. It handles well large volumes of data, handles well many concurrent connections, and so it's web scale. Node.js is web scale. So any questions so far? No. So I'm going to tell you now what I think makes Node great. First one is GFSNIF, which is an acronym for JavaScript is fun and so Node is fun. It was not invented by me. Just to say that JavaScript is a malleable language, so you can, for instance, a function can return a function can be assigned to a variable, passed on as an argument. You can add attributes to a function. You can take an object and change the attributes, add one, remove another. It's very malleable, very plastic language, right? Also, it's a language that allows patterns, easily allows patterns for functional programming. Instead of doing imperative programming, if you use functional programming, you can get quite elegant code in JavaScript. And so that's what makes JavaScript fun to program, is when you start using these patterns that you cannot use in other languages. Because a function in JavaScript is a first-class citizen. A function is a value as a string. So you can pass the function around, and that allows, that enclosures allow a lot of patterns that are very interesting. Also, the JavaScript can become quite messy if you're not careful. So because of this plasticity that JavaScript has, if you're not careful with how you maintain your application, quite easily you'll get a big ball of mud. And so you have to be careful. And that comes with time and practice. Also, JavaScript is built for asynchronicity. So JavaScript was built for basically manipulating the DOM, manipulating a JavaScript object, and also for making HTTP requests, AJAX, right? So it's built from the ground up for asynchronous work. And it's built for asynchronicity, especially compared with other event-oriented platforms. I've used other event-oriented platforms other than Node.js, And I can tell you that Node.js is the easiest one by far to create event-oriented platforms. And I may later explain for those that don't quite understand what event-oriented means. I'll explain a bit later. It's also built for real-time, so it handles many concurrent connections easily. So, which is great for mobile. Because mobile has this problem where clients have a huge latency. So, mobile clients just to reach the tower has 100, 150 milliseconds of delay if the radio is on. If the radio is off, it can be up to 300 milliseconds of delay. And so, one request, as you guys know when using your smartphones, one request can take several seconds instead of when you have fast internet connection at your home, just takes 1 second, 2 seconds at most. So what happens is that it's hogging the resources much more than normal desktop internet-connected devices. Node.js, because of that, Node.js is great for mobile. And that's why LinkedIn, that's why Walmart powered their mobile traffic using Node.js. For instance, PHP, Rails, Django, they use the worker pool module. So the worker pool module is, for you that don't know, is one process serves one request, right? So there's a pool of processes, and when one request comes, the runtime picks an available one and assigns it to that request, and then that process processes that request, and when it's done processing that request, replying, goes back into the pool. Okay? So imagine how this is for request response flows, right? So when there is a request and a fast response, this works kind of well because processes are never occupied by one request for a lot of time. They just should be quite fast, right? So they reply within 500 milliseconds, and then they go back into the pool. For real time, this doesn't happen. Real time requires a permanent connection into the process. The client, for its WebSockets. A WebSocket is a direct connection to the server, and there is an open connection where the server can send data back into the client, as well as the client can send data to the server. And that conversation can go on for for a long period of time. So, if you have to support, let's say, 10,000 concurrent users having real-time open connections, you have to have 10,000 worker processes available for those connections. And if you have applications like, for instance, LinkedIn or Walmart, where they have millions of concurrent users, you'll have to have hundreds of machines just to support all those processes. And so it's not a scalable model, right? But Node, in one process you can have many concurrent connections. It has its downsides, but it's one of the upsides. Yeah. Sorry.
Isn't it bad to a big company that has millions of users to have just one process running at a time? If something's going...
No. Don't misunderstand me. You don't serve all of Walmart using one node process. You probably use 100 or 200 node processes to serve all their traffic. But each node process gets 100% CPU. That's mostly there because of redundancy and load balancing, because each machine can handle so much network traffic, right? And one node process could not handle 200 million users. It can handle maybe 50,000 users or 100,000 users if it's well tuned, but not millions of users. So you have to have a cluster of node processes and have to have load balancing to spread out the load throughout the processes. Okay. Well, it's a similar thing to that, but yeah, I'll show you later some use cases. Also, JavaScript has a very small standard library. And Node.js has a bigger standard library, but still small standard library. And I think this is very good, because a standard library is somewhere that code goes to die. For instance, if people want a new functionality into Node.js, they want to support, I don't know, a strange protocol, strange database protocol. And if you add that protocol into the standard library, people will have to support it. And once there is a new version of that protocol, you have a fork, right? You have to support the previous one and the new one. How do you do that? It's very hard. So people will create a new package to support a new version, and then the old version will eventually not be used anymore, or just be used by the people that use the old version of the protocol. So basically, it's where code goes to die, the standard library. While if you have like small components that you can upgrade and install and uninstall on top of a very small standard library, that's preferable. And also, this is tightly related to this, the Unix philosophy. So this is, I forgot the name, this is Richie, and these are the creators of the Unix operating system, one of the two of the original creators of the Unix operating system. And they say, they describe here Unix philosophy. And Unix philosophy emphasizes building short, simple, clear, modular, and extensible code that can be easily maintained and repurposed by developers other than its creators. Unix philosophy favors composability as opposed to monolithic design. And then Doug McIlroy, which is the inventor of the pipe command in Unix, further extended this and said that Unix philosophy is to write programs that do one thing and do it well, write programs to work together, write programs to handle text streams, because that is a universal interface. And the Node platform embodies this philosophy by favoriting modules and streams. So modules, very tiny modules that do one thing and do it well, and then streams to compose these modules. So it's like Unix for JavaScript. So as I was saying, no standard lib is like the Unix standard I/O in JavaScript. So it supports the main internet protocols with an easy syntax. So it supports HTTP, of course, TCP, DNS, UDP. I don't think much else. And the syntax is very simple. There is no Java constructs. There is no pattern, factory, singleton to instantiate. It's very straightforward. I'll give you an example. For instance, it's very easy to get started. You guys that write Node.js already know this. This is the HTTP server, Hello World HTTP server that fits inside a tweet. It's like 92 characters or something. So it's very easy. So I'm requiring the HTTP module in Node Core, which I'm using to create a server, and I'm passing in a function that is going to be invoked for each connection. That server, I'm making it listen on port 8080. Every time I get a request, I end the request and say hello world. So there's no boilerplate, no ceremony. It's just the code that I need. And also very powerful. In this previous case, I didn't use streams, but here I'm using streams. So I'm. Anyone can guess what this does? This piece of code does. The main difference here from the previous example is the connection handler. Yeah, I'm piping the request into the response. And what this does, any clue? Sorry? Echo. An echo HTTP server. Exactly. So every data that it gets from the request, it pipes into the response. Okay? So I can easily do an echo HTTP server like this. and I can also compose several pipes to create a service here. So I can create a pipe, a stream to transform something or get or enrich the data or process a request, whatever. It's very powerful, and streams, I won't delve too much into it, but streams also allow Node.js to scale. Because like Unix, data is dealt with in chunks, in small pieces. So it does not, the request doesn't occupy memory here. The request is being streamed through the pipe out into this file with just 90 characters. Another reason that I love Node.js is NPM. NPM is a Node package manager. It's several things. It's a repository of packages that are open. So you can browse the packages, you can search for packages, and then you can install packages from it. And you can also publish packages to it very easily. As long as the name is available, you can publish a new package that does something that you like, a Hello World HTTP server, whatever. Oh yeah, and it's a command line tool for doing those things also. So it's a command line tool that comes bundled with Node. So when we install Node.js, you also have NPM available there, and right away you can start downloading, installing packages and using them. And NPM for me is modules done right. There are several versions of the same package. Several versions of the same package can coexist on the same application. There is no conflict here, and it's the first package manager that I see that solves this in an elegant way. And you can later talk to me about how this works, if you're interested on how this works. As I was saying, it's very easy to publish a module. Just have to sign up and then do npm publish, and it publishes. It's very easy also to install a module. NPM has also a lot of modules there, a lot of packages there. As you can see, around June last year, it surpassed the previous biggest one, which was Maven Central. It surpassed it in number of packages. And now it has approximately 150,000 packages, I think, available. Or I think it's more. Which makes it fair to say that there is a Node package for that. If you think of anything computer science related, there's probably a Node package for that. If there is not, you just make one and publish that. Everyone will appreciate it, I'm sure. And NPM discoverability is still a bit of a problem, unsolved problem. The new website makes it easier to find packages, and they group packages in groups of packages. For instance, packages that are related to Browserify or related to Express. There are islands of packages. And people have started using NPM in an interesting way. Not only they publish packages for Node.js, they use it to publish packages for browsers, publish packages for Browserify, packages for jQuery is now publishing also on NPM. So everybody is like congregating into this repo for publishing their JavaScript packages. So this leads to fragmentation, right, in the ecosystem. So as I was discussing a bit earlier with Miguel, every week there's a new framework. Every week there is a new web framework coming out. And this leads to fragmentation, of course. So each team is probably using a different version of a different framework. But also, it also gives you a lot of flexibility. But with power comes great responsibility, and you have to know which packages to use, and also community is a good place, and blog posts to discover what packages are there to solve your particular problem. But it's still an unsolved issue. So now I'm going to give you a few Node use cases. Typical web apps, like a web server that renders templates and talks to a SQL database. You can use Express, it's the most known one. A lot of people successfully use Node.js just for this, like they would use PHP or like they would use Ruby on Rails. They use Express. There are others, but the most used one is Express. Another use case for Node.js is to build a smart proxy. For instance, for the case of LinkedIn or the case of Walmart, they have internal services. For instance, an internal service for order dispatching, internal service for payments, for account management, etc. And this smart proxy, when it gets client requests and talks to the backend services appropriately, and then gathers the results and then replies back to the client. So it serves homogeneous API, so a unified API into the inner network of the service, tying together all these backend services. Very tightly, very coupled to this is the notion of microservices. So this is the extension of the embracement of the Unix philosophy. This is a way of creating services that do one thing and do one thing well. Instead of having a monolithic application that does user management, that does account management, that does session management, that does payments, that does everything, we have one microservice that does each one of these, and then there is somehow these services are all tied together. For instance, the Amazon web page the whole page is composed of hundreds of microservices. And what happens is that when one of these, they are all requested in parallel when there is a page request, they're all requested in parallel. And if one of them fails, or one of them takes longer than X milliseconds, it's okay. You just don't present that part of the page to the user. For instance, if the service that is responsible for showing you your recommended products doesn't reply in time, you just don't render it. Just don't show it on the page. It's more important for a page to appear than it is to show everything on the page, right? You don't want the service to be down. You don't want a fault, a small fault in one of these components to affect the whole customer experience, right? Because the customer may not be interested in that. They may want just to jump right into the product or the shopping basket and then just check out, right? They don't want to know about what products are recommended to them. And this way, people can just go on to doing their life, even though there are services that may be failing or services that they may... And then you can have several teams, each one developing their own service, right? You can say, this is the team that develops accounting, this is the team that develops session management, the team that develops whatever, and they all have their release cycles, and they all are responsible for testing that service, and they all are responsible for keeping it up, and keeping the quality of the service up. And so when you want a change on any of this, it's very easy to make a change. Instead of having a big ball of mud in a monolithic application where everything is suddenly coupled together and you start pulling from one side and everything comes after it, and you just, it's terrible. Most web applications start very small and simple. They rapidly evolve into this big ball of mud. And this is one way, one pattern to escape that problem. So, real-time and WebSockets. Have you guys heard about Socket.io? Yeah, Socket.io? Cool. So Socket.io was, I guess, one of the main reasons people came to Node.js initially. Because it allowed WebSockets an easy API for WebSockets, so real-time communication, not only communication from the browser to the server, but also communication from the server to the browser. You can push things from the server to the browser. For instance, you can make a chat application very easily using Socket.io. And Socket.io not only provides WebSockets for modern browsers, but can also fall back to other strategies for older browsers that don't support WebSockets. So it was, I think, one of the main propellers of Node.js, at least initially, was Socket.io. So that's one use case, real-time WebSockets. And Node scales particularly well because of all the reasons that I've told you. Internet of Things is another one. So, for example, collecting and aggregating sensor data is a very common application. For instance, we recently did a project for British Gas, where they had this boiler at home of the customer. Customers had boilers, and the boilers were connected to the internet, and they were sending data into British Gas. And British Gas collects that data, and then can determine, can make a series of calculations and determine, well, this guy arrives home, and I'm not going to activate the boiler. I'm going to activate the boiler half an hour before he arrives home, so that I don't waste water. It can make decisions, and they've saved millions and millions of pounds of energy just because of this one project. So it's like the ROI, the return on investment on this project was like 2 months or something. Well, besides the business case, Node.js is they use Node.js for exactly this, collecting and aggregating data. So getting data from millions of sources, it's a good use case for Node.js. Okay, so Node.js is a sexy platform, perhaps not so sexy language for some of you, but I like JavaScript. But how does it behave in production, which is, I think, more important? You can see here, I talked about Black Friday in Walmart. This was Black Friday, not last Black Friday. It was 2014 Black Friday. And this is the Aaron Hammer, the guy in front of the development team and the DevOps team. So he felt so good about everything that we decided in the middle of Black Friday is a perfect time for a release. So they did the release in the middle of, and you cannot see the release here. All the CPUs are 1%. And I can tell that they serve 200,000 users online. Using what seems to be like, I don't know, 15 or 20 CPUs serving Node.js. There are a lot of stories like this. For instance, Groupon implemented their system in Node.js, which resulted in page load times dropping by a whopping 50%. LinkedIn moving to Node.js from Rails, and they reduced the number of servers from 30 to 3, and the new system was 20 times faster. I cannot even imagine what they were doing with the old system. It should have been quite gruesome. But there you can find a lot of stories like this on the internet. And I can tell you from a first-person approach that if you do things right, yes, Node.js can scale really, really well. Okay, any questions so far? I'm going to jump into... Yes? Yeah.
To complement
the
example that you said about Walmart and all those changes, in terms of security, was some record about some aspects on security?
Are you asking
if Node.js is security?
Oh, there is a Node.js security project. The thing about the Node.js security is not so much about Node.js core itself, it's more about the packages that you're installing, right? And there is a Node.js security project that does an audit on the most used packages. They have security experts auditing the most used packages. It's led by a company called NTF, which I'll show later, and some friends dear friends of mine that helped there. The community also helps, and there's a process for doing that. So there's all
it's normally that when you have that flexibility, you have a governance with security in the beginning, only after some time of technically being mature, you can achieve some guarantees that everything is working correctly.
I can tell you that these guys were responsible for probably 95% of the code that was running there. Because they built the HTTP, it's all open source, right? But they built it from the ground up. They published a new framework, they published a new testing framework, everything they built. They weren't satisfied with what existed. Not, I won't say because of security reasons, because probably, do a security audit on a piece of code for people that are used to it is kind of easy, but because they said, oh, this is not exactly what I want, I'm going to build another one. So they were familiar with the code, and they're a very particular team, right? They're a very particular team. But there are concerns, of course. But for instance, if you're using Express, an Express server, which is one of the most used frameworks for building web servers in Node.js, I'm sure that there were security issues around that, but they were quickly solved, and everyone knows about that. Those immediately, everybody solves because it's so widely used. If you're using a very obscure package that no one else uses, then you should audit it yourself, right? But there is a Node security project. You can search that online. Node security project that provides early warnings. I don't know exactly what the terminology is here. Okay, so on to the community aspect of it, of Node.js. So there are a bunch of conferences around JavaScript and Node.js. This one I co-founded and helped organize Alex.js. It's about JavaScript, but it's like 80% Node.js usually. More or less the same thing about JSConf in the United States. This one, JSConf Europe in Berlin, also has a high component of Node.js and server-side stuff. NodeConf, obviously, in the United States is the go-to conference for Node. NodeConf Europe is a fun one. It's in Ireland, usually. And there are several others. There's an Italian one called Node.js Italy, I think. And there's Node Summit in San Francisco, which is more business-oriented. And there are others. There's also almost a new conference every day. Also consulting companies, the most known ones in the Node.js world, of course, the one that I co-founded, Yield. StrongLoop has at least two Node.js core committers. Rising Stack, I know the people behind that, they're good people. NodeSource, a lot of San Francisco people. And yet, they're responsible for the Node security project and a lot of peer-to-peer things, peer-to-peer video, peer-to-peer open. I'll remember later. Nearform are the ones that organize the NodeConf Europe. They're in Ireland also, and Debuggable is in Germany. Has at least one previous Node.js core committer. And there are other consulting companies, but these are, I think, the most prominent ones. I'll talk to you about people. So this is the original author. I already talked about him, is Ryan Dahl. He quit the project not a long time ago to work on something else. He left. So Giant acquired Node.js trademark, acquired Node.js source code, and then Ryan Dahl had golden handcuffs and had to work for them for some time. And when that was over, he left and went to New York, be a hipster, whatever. He didn't want to ever touch Node.js again. I don't know what he's working on, but he left the map in what regards Node.js. And then came Mr. Isaac Schluter, which was the benevolent dictator for life #2 of Node.js. He's now the king of NPM Inc., which is a company that runs NPM, which is a private company, which is a bit weird. A private company that runs an open repository. There's also Michael Rogers. Michael Rogers is the person that organized NodeConf. He's the author of many modules, many Node.js modules. He's also a community organizer. He organizes IO.js, which I'll talk about. There's another job. He's my partner in crime in YLD consulting company. He's a great guy. That's why he's here, and also because of his skills in Node.js and business. There's Rod Vag. This is a guy from Australia, extremely talented and nice guy. He's one that's responsible for LevelDB, for the integrating LevelDB into Node.js, the Level Up project. He's also the leader of the IO.js technical committee. This is Bert Belder. He is one of the co-founders of Strongloop, which was one of the companies that I showed you before. He's a Node.js core committer. He's the lead developer of the libuv. libuv is part of Node.js that handles the event loop that's built in C. And libuv is used not only by Node.js but also in other projects. Fedor Dutny, also known as the Crazy Russian. This guy is one that is responsible for upgrading V8 in Node.js. So as I told you, Node.js has the Google JavaScript engine. It's called V8 that powers the Google Chrome browser. This guy is responsible for interfacing with V8 and upgrading V8 and all that crazy stuff. This guy is Substack, James Holliday. He's the most prolific open source author that you guys can ever meet. 3 times that we had conferences in Lisbon, he came 3 times. He spends the half the year traveling. I don't know how he has time. You can see in NPM he has 517 packages published there. And they're almost all prime quality. This guy is Dominic Tarr. He's a fun guy. He's from New Zealand, I think. He's like the wizard of distributed systems in Node.js. He likes peer-to-peer, gossip protocols, weird databases. This guy is a wizard, as you can see from the hat. This guy is a wizard. This guy is Guillermo Rauch. He's the original author of Socket.io. He lives in San Francisco, I think. And there are many, many more people. I just couldn't fit, here in time. And finally, I'm going to talk a bit about IO.js. Have you guys heard about IO.js? Yes? Yes? Okay, no, not many. So I'm going to explain a bit what's up with that. So as I told you, Join owns Node, the Node trademark, and also owns the code. The code has a very liberal open source license, so people can easily contribute to that. And the problem is that until recently, Node spent almost 2 years without a minor release. So it was stuck on the stable version 0.10, and only recently they released 0.12. They spent 0.11 for almost 2 years, which is an unstable version. For almost 2 years. And so people got frustrated about that and created a movement called Node Forward, which was led by this guy, Michael Rogers, and some other guys, to try and push Node forward, right? So people were frustrated because they used older versions of V8 and they wanted the new shiny version of V8 embedded so they could use the new syntax of JavaScript, ECMAScript 6, on their Node projects, and they couldn't, and all sorts of political things going on, and they wanted to liberate Node from the claws of Giant. And so they did a friendly fork, and they created this open governance model where they have like this technical committee. People get invited to the technical committee. There is no official company structure. It's just an open model for governance. And so far, it's been working very, very well. We have IOJS 1.3 now, I think. It's kept up to date every week regarding the V8 releases and patches, except when there is some type of problem. And the main drive here of in the IOJS page is to bring ES6 into the Node community. So to bring the latest features of JavaScript into the Node community. On the other side, Join created a Node Foundation. And there is not much data about the foundation yet. It's a very recent thing. But people, again, are rallying for an open governance model. And there is this website called nodegovernance.io. And you guys can read. So Join recently announced that the new foundation will take control of Node. Important details about how the foundation will work have not yet been decided. Now is the time to tell Join CEO Scott Hammond that you'd like IOJS's open technical governance model to form the basis for the Node Foundation's technical committee. So they want to free the Node.js from the needs of one or a few large companies, but rather be determined by the technical leaders who represent the spectrum of Node use and users. So they're trying to free Node.js from the shackles of large companies. Let's see how that pans out. IOJS is still cutting edge right now, but people will eventually start adopting it in production. You can say that it is as stable as the current stable version of Node, which is pretty stable, and it's faster in many cases. So I foresee that either one of two things will happen. Either there will be a merge and an open governance model on Node.js, and the two projects will merge eventually, or people will start using IOJS because it's more up to date. And just so you guys have a notion, you had like 3 or 4 core committers when this project was enjoined, and now you have like 13 or 14 core committers in IOJS in just a few months' time. So the progress has been great since IOJS has been formed, which is great for everyone, right? So meanwhile, keep calm and node on, and thank you. Questions?
Yes. You haven't addressed the main issue that I brought to this presentation. That is Node.js able to work with operating system calls, like managing file system, creating files in file system, or something like that? Or I believe that was a constraint. Is it still a constraint?
No. Node.js from the get-go, it has a FS module that is able to operate with the file system. Yes. JavaScript not on the browser, not. But Node.js on the server has FS.
Can I make a system call to execute some program and then get the result from?
Yes,
the
you can do exec. You can do spawn. You can control. You can control see the output of the new process. It's very flexible. It's very flexible. In terms of, it's almost like you have everything that Unix has in terms of system calls, but with the JavaScript API.
How's the progress coming along with PM2, being able to restart Node when it eventually errors out?
I don't know much about PM2. I don't use PM2.
Or forever, or
yeah, well, I'll use forever, or even use Upstart and stuff like Monet. And quite frankly, I don't know about PM2. I haven't used PM2. I don't know anyone that uses it. Is there an issue?
I mean, I think the issue was that Node would the way that exceptions are handled in Node.js, it's difficult to catch exceptions that come from client libraries.
Well, yeah. So one of the advantages of Node being able to handle many concurrent connections is that Node is able to handle many concurrent connections. But one of the problems is that when an error occurs, if that's not handled properly, what happens is the whole process dies. And it's not a problem of PM2, it's a problem of Node.js. And it's partially been solved with domains. So what domain, you can, when there is a thrown and a caught exception, but it's wrapped in a domain, you can see for instance, in an HTTP server, see which request it was belonging to. So you can just close the response and say, oh, 500 error. I have a 500 error, and terminate that. But given the nature of Node.js, you still could end up having memory leaks because of that, or at least resource leaks because of that. Because you're left in an undefined state because you don't know when the exception occurred. If you had an open database connection, you need to close it, for instance. You want to get a chance to close it. You can track it and close it. But what people normally do is when there is an uncaught exception, what you do, you try to terminate the server, wait for all the clients to terminate their requests, and then shut down the service. But you have a lot of, typically you have more than one Node.js process in the same machine in load balancing. So that won't affect your service, right? If you have it well prepared using the cluster module, you won't have any downtime, or shouldn't have any downtime. And there are also techniques for making zero downtime deploys, using techniques around that. So there's this issue of error handling, but it's addressable. Depends on the type of application.
I think it's just as long as you're not keeping too much state in a given process.
Right.
Understanding that you might need to take it.
Yes.
You might have to go down.
If you're getting too much state in one process, you lose the whole section, and that can be bad. If you don't, you're safe. You can just load. The client can reconnect to another process, and that's fine.
Do you mind if I make a plug for something that I'm working on?
Sure.
So if you guys are interested, I started a Funchal JavaScript meetup a couple weeks ago. I hadn't arrived at Funchal yet. But if you're interested in JavaScript and these kinds of topics, join the group on meetup.com and we will arrange a time to get together.
Cool. That's fine. That's great. What do you have any planned meetings already?
Not yet. I'm still trying to figure out where we can meet and if it, I don't know. There's a few people who've joined, but yeah. So if anyone wants to help with that, that's welcome also.
Yeah, I would. I don't work here, but I can definitely help. Cool. That's good.
One of the things I see a lot mostly in startups, they use Node.js in production, is that it's something that you usually do with, otherwise you could be doing in PHP or Rails. But they do, for some reason or another, just maybe because Node is kind of sexy, as I say right now. But my problem about it is that I see a lot of these people working with NoSQL database instead of MySQL or
Postgres.
Postgres, exactly. Why MongoDB in this context?
Well, why MongoDB? So it's kind of not related to Node.js, but it kind of is. So you can have a schema-less data store, and Node is you can do quick prototyping using Node, right? And you can, from the get-go, you don't know your schema of the database, right? So if you use something like MongoDB, you can quickly adapt. I mean, just insert a new field and it will accept it. Just embed a document in there and it will accept. You don't have to do migrations and change columns and etc. Which is very, I think, very helpful. At least from an early stage where you're evolving, you just shove data into it and that's it. CouchDB also has a document store, and I really appreciate that side of it, where you don't have to think up front on the schema. I think it's really useful. So they kind of both go together because of that. Node.js is JavaScript, really malleable. MongoDB, the document store, you can insert any type of document, really malleable also. So, yeah. Sure.
The same topic. Is it a good idea to use CassandraDB since Cassandra you have to prepare the schema?
Well, I haven't used Cassandra, in production. I've tried using it. Yes, Cassandra, you have to define the schema. So
At the
it's
same time, no SQL.
well, yeah. And you can also use MongoDB with schema on the client side. So you can, for instance, if you use Mongoose, you have to define the schema for the data. So it kind of goes, but Cassandra needs it because of a technical aspect of it. So to manage the concurrency into certain column values, it has to have that. I think it's because of that. But it's a bit of a conundrum, yeah. I agree. But I don't see many applications requiring a database like Cassandra from the get-go. I would start with something simpler than Cassandra because to set up Cassandra is just...
I'm working on a project and we are starting with Cassandra.
Okay.
That's why.
Good luck.
It's a little bit difficult compared with MongoDB.
Yeah, it is.
It's really hard.
It is, especially to set up. But it's interesting technology. It's interesting. Yeah.
Which server-side web frameworks are you supporting on right now? I mean, I know that there's Sails is a fairly new one.
Yeah, Sails is a new one for people that like Railsy type of stuff, where you have like MVC and the database wrapper is handled for you, etc., and migrations, and if you use a relational database, especially, it's more purposed for that spectrum of applications. Sails is cool. Also combines the Socket.io with so it's also you can have a WebSocket to the client, and you can combine that into a user session. Very useful, which can be kind of troublesome if you do it by hand. And Sails just solves that. You just have to concentrate on the controller code and templates, and that's it. So it's kind of useful. But I use Sails once in production. But mainly I use Happy.js and Happy.js, and Restify, and I've used Express before, but not use Restify when I want to provide REST APIs only. That's what I usually use. But yeah, there are new ones that I haven't had the time to explore, and variations on Express, several of those. I don't really like the middleware model that Express uses and Restify also uses. That's why sometimes I prefer Happy. But Happy also has a bunch of other features, that built-in authentication and message signing, which is really useful.
What are the requirements for the web server to have Node.js? Is it difficult to install?
Well, no, it's really simple to install Node.js. There's an up-to-date, there's some quirks for installing it using a Debian package, but it's kind of easy. I know that there's a new, I don't know how you call it, a new deb, a new channel, whatever, that you can use to install Node.js, the latest Node.js, and the latest IO.js also. So it's really easy to install. There are Docker images for Node.js, custom images for all the latest releases of Node.js. Sometimes people use Docker for deploying. It's getting more and more common to use Docker to deploy now. But mainly, well, the typical way is just to have create a server in AWS, stock Ubuntu, and then go through a bunch of configurations to optimize the number of maximum concurrent connections, blah, blah, blah. Then install the stock compile Node.js on the machine, and then create a snapshot from there, and then you can replicate all the machines that you like from that image. That's one technique that sometimes I use. There are other alternatives. Yeah, Docker. There are Docker images for. I think one of these companies, NodeSource, I think. Yeah. This one, Node source, I think has official Docker repos for Node.js. Any more questions? Regarding Node.js or anything else? Around Node.js?
For example, imagine you have a cluster of node processes. How do you keep the session ID since the same user can connect to a process and connect to next process next to it?
Yeah, there are some ways to solve that. One of those is to have a centralized session management system, like for instance Redis, a Redis server where every session goes there. For instance, Socket.io, you can use Socket.io with the Redis server, and so that clients can connect to any of the node processes, and they always get the same session.
Still you have another call to another.
Yeah, so it's not kept in memory inside the process, right? The other option is to have sticky sessions. And you can configure load balancer to have sticky sessions. Like, for instance, use a session ID cookie or something to always use that process. If the process is there, if the process goes down, you lose your session, right? So those are
What's the most common?
the most common one.
way? Yeah.
Well,
Use the database to store the session IDs or using the cookie as you said?
it uses the cookie. The cookie has a session identifier, which is usually signed, and then the session is stored in a central place, typically. And what you do is, when the request comes, you load the session, make changes to the session. After the request is terminated, you save the session back into the session store. It's
very important to scalability.
yeah,
Scale.
yeah. Having a single point of failure is also a bad thing. I have one Redis server where everyone has to go for the session is bad. I've seen many deployments that don't use server-side sessions successfully, and I think it's preferable if you can keep a session on some servers. No stuff on the server means that the client can connect to anyone and you can just load balance through. Okay. Any more questions? No, don't be shy. No? So if you guys want the resources to get started on Node.js, I can point you several ways. There are Node schools, which are fine. If you want to get started, use go to Node school. There are several self-administered courses there. There is Learning Nodes, I think it's called Learning Node website. There is there's another thing about Max. I can't remember, which is Way of Nodes. Nodes. I don't have internet. I think I may try this. Oh, I don't have internet. New computer. No internet. Nice. So no internet. Sorry. I think it's the Way of Node. I think it's called by Max Ogden, which was one of the people that I missed out from here. He's also a very